At the end of the yesterday's derivation, not yesterday's, last period derivation, we got E bar is equals to lambda 2 pi epsilon r into n cap, where lambda is the derivation regarding the electric field at a point P, but a charged body. Field ಬರಬೇಕು ಅಂತ ಒಂದು ಚಾರ್ಜ್ ಇರಲೇಬೇಕು ಹೌದಾ by a charged body. What is the charged body? So here it is a wire of straight wire and extends up to infinity, infinitely long straight wire. The field at a point P. Here is charged body, it is a continuous charge distribution. Suppose a wire is charged, a shell is charged, a plate is charged, the charges distributes all over the surface continuously. Therefore, the charge distribution is continuous one, not a discrete one. Charge discrete distribution. Okay. If the charges are tightly packed, electrons are tightly packed, protons are therefore continuous charge distribution. Okay. So here is the line, continuous charge distribution is there on the line, and at the point P, the charge around the charge body is a field, and the linear charge density lambda equals to it is Q upon L the length of the wire line segment. It is uniformly charged. L is the any line segment, length of any line segment, full length alone. It is not full length because L is infinity avaruttaga. So line segment, okay. Q is the charge on it, on that line segment, okay. L is not the full length, a line segment, okay. So we have taken a Gaussian cylindrical surface of height L. So L is the height of the wire or cross section of the wire or height of the Gaussian cylindrical surface. And point P, so it is distance R. At this point P, field is what? Given by the formula lambda. Lambda is equal to linear charge density Q by L. Real here. This is L. Okay, charge unit is Q. Then charge density lambda is Q upon L, charge per unit length. Epsilon is the absolute permittivity of the free space. R is the distance between the point where the field is to be assessed. Field at a point. In the beginning, field at a point. On the point, field is to be. So around a charged body. Okay, charged body. So the field is electrical field. On the point, field is. That is what it is. The expression here. Field at a point, which is at a distance R from the charged wire. Okay. N cap ಬಗ್ಗೆ ನಾವು ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಷನ್ ಲಾಸ್ಟ್ ಇಯರ್ 30 ಮಿನಿಟ್ಸ್ ವಿಡಿಯೋ ಆಗುತ್ತೆ ಒಂದ್ಸರಿ ಐ ಕ್ಯಾನ್ ಶೂಟ್ 30 ಮಿನಿಟ್ಸ್ ಎಟ್ ಎ ಟೈಮ್ ಲಾಸ್ಟ್ 1 ಮಿನಿಟ್ ಇದ್ದಾಗ ನನಗೆ ಎನ್ ಕ್ಯಾಪ್ ಬಗ್ಗೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಬಂತು ಸ್ವಲ್ಪ ವಿತಿನ್ 1 ಮಿನಿಟಲ್ಲಿ ಮುಗಿಸ್ಲಿಕ್ಕೆ ಹೋಗಿ ಸ್ವಲ್ಪ ಗಡಬಡೆ ಮಾಡಿದೆ ಸೊ ಆ್ಯಕ್ಚುಲಿ ಎನ್ ಕ್ಯಾಪ್ ಈಸ್ ರೇಡಿಯಲಿ ಇನ್ವರ್ಡ್ ಆ್ಯಂಡ್ ಔಟ್ವರ್ಡ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ತೊಗೊಂಡ್ರೆ ರಾಂಗ್ ಅಬ್ಸಲ್ಯೂಟ್ಲಿ ರಾಂಗ್ ಎನ್ ಕ್ಯಾಪ್ ಇದೆ ಯೂನಿಟ್ ವೆಕ್ಟರ್ ರೇಡಿಯಲಿ ಔಟ್ವರ್ಡ್ಸ್ ವಾಟ್ ಯು ಮೀನ್ ಬೈ ರೇಡಿಯಲಿ ಔಟ್ವರ್ಡ್ಸ್ ರೇಡಿಯಲಿ ಅಂದರೆ ಅವತ್ತು ಹೇಳಿದ್ರೆ ರೇಡಿಯಲ್ here is the charge, okay, point charge, here is the point P. The line between the charge and the point is called radial line, okay. Radially outwards, normal to the wire. Radial line hegirutte, normal to perpendicular. The word, try to understand the word normal is perpendicular. Perpendicular to wire, and the direction of N cap is always outwards, not inwards. I have taken during the explanation N cap inwards and outwards everywhere. No, the charge is negative inwards anta ಹೇಳಿದ್ರೆ N cap is inwards, charge is positive N cap is outwards anta ಹೇಳಿದ್ರೆ. Now I will clarify the direction of N cap, always radially outwards. So still the field may be inwards also. How it is? Look here. If the charge is positive, ಆಗ ಏನಾಗುತ್ತೆ? Charge is positive, lambda is equal to Q by L. Q is positive, Q by L. Q is positive, L length is always positive. ಆಗ ಏನಾಗುತ್ತೆ? Lambda is positive, pi is positive, epsilon is 8.54 positive number, R is distance always positive. Even positive number then so positive number N cap is always in this direction outwards. Therefore positive into N cap the field is in the direction of N cap, means field is radially outwards. So field is try to understand the direction of field. If charge is negative on the wire, Q is negative ಆಯಿತು. ಆಗ Q ನೆಗೆಟಿವ್ ಆಯಿತು ಅಂದರೆ ಲ್ಯಾಂಬ್ಡಾ ಏನಾಯಿತು? ಮೈನಸ್ ಅಪಾನ್ L is ಪ್ಲಸ್, ಮೈನಸ್ ಅಪಾನ್ ಪ್ಲಸ್ is ಮೈನಸ್. ಲ್ಯಾಂಬ್ಡಾ ನೆಗೆಟಿವ್ ನಂಬರ್ ಆಯಿತು, ನೆಗೆಟಿವ್. ಈಗ ಏನಾಗ್ಬಿಡುತ್ತೆ? ಇದು ನೆಗೆಟಿವ್ ನಂಬರ್, ಹೌದಾ? ಆ ನೆಗೆಟಿವ್ ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಮಾಡ್ತೀಯ, ದ ನೆಗೆಟಿವ್ ಸೈನ್ ಓನ್ಲಿ, ಆ್ಯಂಡ್ ಇಟ್ is the magnitude of the field. ಇಲ್ಲೊಂದು ಲ್ಯಾಂಬ್ಡಾಕ್ಕೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಬರುತ್ತೆ, ಬಿಕಾಸ್ ಕ್ಯೂ ಇದು ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ, ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್. ಆ ಮೈನಸ್ ಸೈನ್ ಅನ್ನು ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಮಾಡ್ಕೋತೀಯ ಎನ್ ಕ್ಯಾಪ್ಗೆ, ಮೈನಸ್ ಎನ್ ಕ್ಯಾಪ್ ಅಂತ ಹೀಗೆ. Now the field will be in the direction of not n cap minus n cap. ಹಾಗಾಗಿ ಮೈನಸ್ ಎನ್ ಕ್ಯಾಪ್ is inverse. ಆಗ field automatically inverse. ಹೌದಾ? The charge is negative and the field is towards the charge. ಈ ಆಗ ಲ್ಯಾಂಬ್ಡಾ ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ, ಚಾರ್ಜ್ ಇಸ್ ನೆಗೆಟಿವ್, ಲ್ಯಾಂಬ್ಡಾ ಈಸ್ ಕ್ಯೂ ಅಪಾನ್ ಎನ್, ಕ್ಯೂ ಇಸ್ ನೆಗೆಟಿವ್, ನೆಗೆಟಿವ್ ಅಪಾನ್ ಪಾಸಿಟಿವ್ ಇಸ್ ನೆಗೆಟಿವ್, ಲ್ಯಾಂಬ್ಡಾ ನೆಗೆಟಿವ್ ಆಯಿತು. ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್. ಆಗ ಮೈನಸ್ಸನ್ನು ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡ್ತೀಯ. ಲ್ಯಾಂಬ್ಡಾ ಅಪಾನ್ 2 pi epsilon naught, ಲ್ಯಾಂಬ್ಡಾ ನೆಗೆಟಿವ್ ಇದೆ, ಓನ್ಲಿ ಮೈನಸ್ ಸೈನ್ ಇಸ್ ಶಿಫ್ಟೆಡ್ ಟು ಎನ್ ಕ್ಯಾಪ್, ಮೈನಸ್ ಎನ್ ಕ್ಯಾಪ್ ಆಯಿತು. therefore this is the magnitude, a positive number, magnitude is always a positive number, and this is minus n cap ಆಗ್ಬಿಡುತ್ತೆ. ಲ್ಯಾಂಬ್ಡಾ ನೆಗೆಟಿವ್, ಆ ನೆಗೆಟಿವ್, ಲ್ಯಾಂಬ್ಡಾ ಈಸ್ ಮೈನಸ್ 10 ಸೆ. ಆಗ ಈ ಮೈನಸ್ 10 ಅಲ್ಲಿ 10 ಅನ್ನು ಇಲ್ಲಿ ಉಳಿಸ್ಕೋತೀಯ, ಮೈನಸ್ ಅನ್ನು ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡ್ಬಿಡ್ತೀಯ. ದಿಸ್ ಇಸ್ ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಯಿತು. ಸೊ ಎವ್ರಿಥಿಂಗ್ ಈಸ್ ಪಾಸಿಟಿವ್ ನಾವು. ಲ್ಯಾಂಬ್ಡಾ is minus 10 into only 10 is taken and minus is shifted here. So 2 pi epsilon naught, because magnitude of a physical quantity is always positive. And minus n cap ಆಯಿತು, ಈ ಮೈನಸ್ ಅನ್ನು ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ದೀವಿ. ಚಾರ್ಜ್ ಇಸ್ ನೆಗೆಟಿವ್, ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ನೆಗೆಟಿವ್, ಆ ನೆಗೆಟಿವ್ಲಿ ಓನ್ಲಿ ಪಾಸಿಟಿವ್ value of the lambda is taken, minus is shifted to n cap. Therefore, no, this gives always, cap gives the direction, unit vector gives the direction of any vector. Suppose a bar is equals to a into a cap, this is the magnitude, a positive number, this is the what it is, unit vector which gives the direction. Okay, from this a bar. ಇವಾಗ ಏನಾಗುತ್ತೆ, in the direction of e bar is in the direction of minus n cap. n cap is radially outwards always. ನಾನು ಏನು ಹೇಳಿದೆ, ಎನ್ ಕ್ಯಾಪ್ ಇಸ್ ರೇಡಿಯಲಿ ಔಟ್ವರ್ಡ್ಸ್ ಆರ್ ಇನ್ವರ್ಡ್ಸ್ ಅಂತ ಹೇಳಿದೆ. ಯಾಕೆ ಇನ್ವರ್ಡ್ಸ್ ಅಂತ ಹೇಳಿದೆ ಅಂದರೆ ಚಾರ್ಜ್ ಇಸ್ ನೆಗೆಟಿವ್ ಆಗಿ ಇನ್ವರ್ಡ್ಸ್ ಬರುತ್ತೆ ಅಂತ ಈ ದೃಷ್ಟಿನಲ್ಲಿ ಹೇಳಿದೆ. ನೋ, ಎನ್ ಕ್ಯಾಪ್ ಇಸ್ ಆಲ್ವೇಸ್ ರೇಡಿಯಲಿ ಔಟ್ವರ್ಡ್ಸ್. ಈ ಚಾರ್ಜ್ ಇಸ್ ನೆಗೆಟಿವ್, when you are writing one minus here, minus is taken to minus n cap, then automatically the direction of the field will be minus n cap. Minus n cap is one, which is n cap is radially outwards, therefore minus n cap is radially inwards. In that case, field is radially inwards. Quite obvious. If the charge is negative, field is radially inwards. If the charge is positive, field should be point is radially outwards. Therefore, n cap bidirectional alla. n cap is unit vector. That person last year n cap explanation na barkondirtira. n cap is unit vector radially outwards, normal to the wire. This is the wire. ಇದಕ್ಕೆ perpendicular ಆಗಿ ಹೀಗೆ n cap ಬರುತ್ತೆ. What is the direction? Outwards only. But field may be outwards or inwards. If the charge is positive, then so here only plus n cap you are getting, our field is radially outwards. If the charge is negative on the wire, then automatically minus n cap ಆಗಿರುತ್ತೆ. Here you are getting lambda negative, ಆ ನೆಗೆಟಿವ್ ಸೈನ್ ಅನ್ನು n cap ಗೆ ಶಿಫ್ಟ್ ಮಾಡ್ಕೋತೀಯ, ಮೈನಸ್ n cap ಆಗಿರುತ್ತೆ, automatically field is radially inwards. Field is radially outwards or radially inwards according to the charge is positive, charge on the wire is positive or negative. But n cap is a unit vector, always radially outwards. Okay, understand ಆಯ್ತಾ? ನಾನು ಗಡಬಡನಲ್ಲಿ n cap is outwards or inwards ಎರಡು ಹೇಳ್ಬಿಟ್ಟೆ. In the but it is in the point of if charge is negative, field is outwards, sorry inwards, charge is positive, field is outwards, outwards and inwards ಎರಡು ಬರುತ್ತೆ field. ಅದಕ್ಕೆ n cap outwards inwards ತಗೊಂಡೆ. No, n cap is unidirectional, radially outwards. Radially means the wire ಅದಕ್ಕೆ perpendicular ಆಗಿ n cap ಹೊರಗಡೆ ಬರುತ್ತೆ, ಆಯ್ತಾ, outward direction ಇರುತ್ತೆ. But if the charge is positive, automatically field is in the direction of n cap. Charge is negative ಆಯಿತು ಅಂತಂದರೆ automatically lambda negative ಆಗುತ್ತೆ, ಮೈನಸ್ ಸೈನ್ ಅನ್ನು ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಮಾಡಿಬಿಟ್ಟು, so the field will be in the direction of minus n cap. Minus n cap. n cap is outwards and minus n cap is inwards. If a bar is a vector, then minus a bar is a vector opposite in the opposite direction of a bar. Therefore n cap outwards and minus n cap inward ಆಗಿರುತ್ತೆ. Quite obvious. If charge is negative, then the field should be inwards. Inwards means towards the direction of the field is. Direction, I'm talking about the direction. Inwards outward means direction. So the field is what it is, towards the charge. The direction of the field is towards the charge. Automatically, so field is charge is negative ಆಯಿತು, lambda negative, ಆ ನೆಗೆಟಿವ್ ಸೈನ್ ಅನ್ನು ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಮಾಡ್ಕೋತೀಯ, ಮೈನಸ್ n cap ಆಯಿತು, the direction is always equal to the direction. Therefore, the direction of the field E bar is in the direction of minus n cap. n cap is outwards, minus n cap is inwards. Therefore, automatically field will be inwards. ನೋಡಿ, ಎಷ್ಟು ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಹೌದಾ? So that n cap gives the direction of field E bar even though the charge is positive or negative, but n cap is radially outwards. Now coming to one more important derivation, according to my opinion, irreversible, either linear or irregular. One derivation ಕೇಳ್ತಾನೆ. Last year spherical shell ಬಗ್ಗೆ derivation ಕೇಳಿದ್ದ, but ಆ spherical shell ಈ ವರ್ಷ ತೆಗೆದುಬಿಟ್ಟಿದ್ದಾರೆ out of syllabus. Now look here, field due to another symmetrically charged body. By Gauss's law, you can work out the field at a point when a symmetric body is uniformly charged. Uniformly charged means charge distribution should be same. So somewhere concentration of the charge is more and somewhere concentration of the charge is less. Not like that. Charge is uniformly distributed and continuously distributed, tightly packed on the surfaces. So discrete distribution of single point charge, it has attained to another charge is there. There is a discrete charge distribution. Separation between the charges are there. Then there is a discrete charge distribution. If a wire is charged or a plate is charged, automatically the charges are tightly packed, electrons and protons are tightly packed, so no what it is, separation between them. In such cases the charge distribution is called continuous charge distribution. Okay, even though individual charge is discrete, electron is a discrete charge, but their distribution is, spreading is continuous one, no gap between them. Just like ant line, when the ant line, individual ant is a discrete one, separate single body alva, or the ant line the ant line iduve line modilva, you know, continuous line concept. For similarly, what is a line? Line is set of points alva. Point is a discrete entity, but adana line alli draw madavaga enagutte, all the points are tightly packed, one in touch with the another, so that all the points are continuously distribution, no separation between them. Separation andre discrete agutte, no separation, continuous. Okay, ivaga idakku ಒಂದು plate, here it is, you can heading field due to uniformly charged infinite plane sheet, means ಒಂದು plane sheet ಇದೆ, here is the plane thin sheet. So iದ್ರ ಮೇಲೆ charge ಮಾಡಿದ್ದೀವಿ, but it is length is extends up to infinity, length and breadth extends up to infinity, a hypothetical one. So length and breadth is infinite, is like that, the size of the plate is infinite, length and breadth is infinity, but now ಅದನ್ನು ತಗೊಳ್ಳಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. So here is the whole sheet, and we have taken positively charged on a surface area, the charge is there, therefore ಇಲ್ಲಿ ಯಾವ charge density ಬರುತ್ತೆ, suppose on a line conductor charge is there, there comes the linear charge density. Linear charge density, density ಅಂದ್ರೆ ಏನು, what you try to understand some common words, density, population density ಅಂದ್ರೆ ಏನು, the number of persons per square mile area, ಒಂದು ಸ್ಕ್ವೇರ್ ಮೈಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ, ಒಂದು ಸ್ಕ್ವೇರ್ ಕಾರವಾರ ಪಾಪ್ಯುಲೇಷನ್ ಡೆನ್ಸಿಟಿ. ಸೊ ಒಂದು ಸ್ಕ್ವೇರ್ ಮೈಲ್ನಲ್ಲಿ 1 ಮೈಲ್ ಲೆಂತ್ 1 ಮೈಲ್ ಬ್ರೆಡ್ತ್ ಇನ್ ಸ್ಕ್ವೇರ್ ಏರಿಯಾ ತೊಗೊಂಡ್ರೆ ಅದರಲ್ಲಿ ಏನು, ಹೌ ಮೆನಿ ಪೀಪಲ್ಸ್ ಆರ್ ದೇರ್, ದಟ್ ಇಸ್ ದ ಪಾಪ್ಯುಲೇಷನ್ ಡೆನ್ಸಿಟಿ. ಓಕೆ, number of peoples per square mile area is called population density. Similarly, number of charges per unit length of a wire is linear charge density. Number of charges, amount of charges per unit area, if the charges is spread on the area, then it is called surface charge density. Suppose charges are spread in the space ನಲ್ಲಿ charges distribute ಆಗಿದ್ದಾವೆ, then the charge per unit volume, space into volume ಬರುತ್ತೆ, is called volume charge density. Okay, so here is the plate ಮೇಲೆ charge spread ಆಗಿದೆ, so therefore linear charge, sorry, surface charge density. So consider, look here, read out the ಅಕ್ಷರ ಸ್ವಲ್ಪ ನನಗೆ ತಿಳಿದ್ಬಿಟ್ಟು ಸಾಧ್ಯವಾದ ಮಟ್ಟಿಗೆ ಚೆನ್ನಾಗಿ ಬರೆದು ಬೋರ್ಡ್ ಮೇಲೆ ಬರೆದಿದ್ದೇನೆ, ಅದನ್ನು ನೋಟ್ಸನ್ನು ಸರಿಯಾಗಿ ಬರ್ಕೊಡಿ. ಆಯಿತಾ, ಟಿ ವಿ ಸ್ಕ್ರೀನ್ ಮೇಲೆ ಹಾಕಿದರೆ ಅಕ್ಷರ ಪ್ರಾಬ್ಲಮ್ ಆಗೋದಿಲ್ಲ, ಮೊಬೈಲ್ ಮೇಲೆ ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ ಆಗುತ್ತೆ. ನಾನು ಓದ್ತೇನೆ, ಐ ಆಮ್ ರೀಡಿಂಗ್ ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆ್ಯಂಡ್ ಟ್ರೈ ಟು write on the notes on the basis of my reading. Consider a uniformly charged, infinitely long, plane, thin sheet. So that's the end of the statement. One thin sheet is charged, the size of the plate is infinite. Okay, sheet is infinite. Sigma is equals to Q upon A. Charge per unit area. Area charge ಆಗಿದೆಯಲ್ಲ, ಲೈನಲ್ಲಿ ಚಾರ್ಜ್ ಆಗಿಲ್ಲ, ಏರಿಯಾ ಒಂದು ಏರಿಯಾ is charged. Therefore, Q upon A is the surface charge density of the sheet. Sigma is equals to Q upon A is the surface charge density per sheet, means charge per unit area. Density means charge per unit area here. The charge is on the area, not on the wire line. Line in the previous example, the linear charge density lambda is taken, it is Q by L because the charge is stored on a line. Here charge is stored on a surface area. Therefore, here comes the what it is surface charge density sigma, symbolic sigma Q upon any charge per unit area is the surface charge density of the sheet. X-axis is normal to the sheet. We have taken X-axis as normal to the sheet. The sheet is normal to the perpendicular. X-axis sigma 2. X-axis sigma and Y-axis is coming like this. This is the X-axis. This is X-axis. X, Y, Z axis are perpendicular to each other. Y-axis sigma this is the sheet. ಈ ಕಾನ್ಸೆಪ್ಟ್ ಒಂದು ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ ಡೆರಿವೇಶನ್ ಈಸಿ ಆಗುತ್ತೆ. ದಿಸ್ ಈಸ್ y axis and this is z axis. X, y, z axis are, look here, y axis and z axis are lying on the plane and x axis is perpendicular normal to the plane. ಇವಾಗ there is no flux along y axis and z axis. ಯಾಕಪ್ಪ ಅಂತಂದರೆ so this is the ಅಲ್ವಾ y axis and this is the z axis which are parallel to the sheet, charged sheet. Parallel ಇದ್ದಾಗ the surface is parallel. There is no flux through the y-axis ಅಂತಲ್ಲ y plane as well as x plane, the plane containing z plane, z axis ಅನ್ನು ಕಂಟೈನ್ ಮಾಡಿರುವಂಥ ಪ್ಲೇನು ಹಾಗೆ y-axis ಅನ್ನು ಕಂಟೈನ್ ಮಾಡಿರುವಂಥ ಪ್ಲೇನು ನಮ್ಮ arm itself ಇದ್ದ ನಮ್ಮ palm itself ಇದ್ದ ಪ್ಲೇನ್. ಸೊ ಈ ಪ್ಲೇನ್ ಮೇಲೆ ಫ್ಲಕ್ಸ್ ಬರುವುದಿಲ್ಲ. ಯಾಕೆ? ಸೊ here it is, what it is, the planes are parallel. I think sheet is parallel idre, so if the area element is parallel to the direction of the field, then there is no flux through it. Only flux is maximum through a plane where it is perpendicular to the what it is field. So z axis so hagene idu z axis, z plane means plane containing z axis, idra mele flux barudilla because the field and the plane are parallel to each other. Hagene, so but this is the plane containing x-axis. This plane is perpendicular to the sheet. Therefore, if the area element is perpendicular to the direction of the field, flux is maximum. If the area element is parallel to the field direction, then there is no flux through it. Okay. So therefore, no flux through the plane containing y-axis and z-axis. Only flux is through the plane which is containing what? X-axis. ಇವಾಗ x-axis plane. Okay. ಈಗ ನೋಡಿ, consider a cylindrical Gaussian surface. E bar is along x-axis. The electrical field E bar is along x-axis. Y-axis, z-axis, because y-axis and x-axis is parallel to the sheet. The field E bar is coming only along the x-axis direction. No field is in the direction of y-axis and z-axis because y-axis and z-axis are parallel to the sheet. Okay, sheet is parallel. Consider a cylindrical Gaussian surface. I have taken cylindrical. Textbook the cylindrical Gaussian cylindrical surface taken is parallelopipe. Parallelopipe ತಗೊಂಡಿದ್ದಾರೆ. Parallelopipe diagram ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗುತ್ತೆ ಅಂತ ನಾನು I have taken a cylindrical. Cylindrical, any Gaussian surface you can take. Easy drawing ಗೆ cylindrical ತಗೊಂಡೆ. Even we can take parallelopipe also. Parallelopipe is taken. One and the same. Cylindrical ತಗೊಂಡು ತಪ್ಪು ತಿಳ್ಕೊಬೇಡಿ. Even in the textbook it is mentioned. You can take even cylindrical also. Okay. So cylindrical. This is the cylindrical Gaussian surface. So this sheet ನಲ್ಲಿ this is the cylinder set. So cylinder is passing like this. Okay. Now consider a cylindrical Gaussian surface of cross-sectional area A. This is the cross-sectional area of the cylindrical surface. Okay, the Gaussian surface is passing through it like this. Okay, cylinder is passing through the sheet. In entry activity, some portion is out here, some portion is here like this. Okay, and flux is crossing only two cross-sectional area. There are two cross-sectional area. This is the one. This is the two. Okay. Two cross-sectional area. Flux is crossing only the two cross-sectional area of the cylinder because theta is 0. Now look here. This what it is. This is the what it is cylindrical cross-sectional area, and it is actually this one is actually perpendicular to the field, direction of the field, perpendicular to the direction of the field. For this cross-sectional area, normal is drawn. Then angle between the normal and the E bar is what? E bar is 0. Therefore, the flux is passing through the cross-sectional area. What about the flux through the curved surface area? Flux through the curved surface area is the Gaussian cylindrical surface. He pass agide. So this is the curved surface. This is a cross-sectional area, top and the bottom. No flux is passing through because look at the charge. So here it is, the field direction is like this. Field is always radially outwards or inwards. No, direction of the field is always radially outwards or inwards to the charge. So field is like that. ಈಗ cross curved surface ಗೆ normal draw ಮಾಡಿದೆ. ಹೀಗೆ normal. Okay. So direction of the field is like this, E bar. So what is the angle between the normal and E bar? This is the E bar direction. Always the charge field is radially outwards or inwards. Normal to the charge. Okay. So normal to the sheet. Okay. So here is the charge. Then the field is like this. At a point field is like this. At the point, here is the charge Q, here is the point P, the field is radially along the line join of the charge and the point. So, E point field here is the charge along this line, only along this line. No field is along the y-axis and z-axis. Okay. Therefore, so field is, look here, field is in this direction, E bar, and normal to this curved surface. E curved surface is normally right here. These are the curved surface like this. So, therefore, what is the angle between the normal and the direction of the field? E, 90. Therefore, if theta is 90, theta is the angle between the normal to the area element and the field E. Then theta is 90, no flux is passing through it. But here the normal to this cross-sectional area is normally like this, perpendicular. So, this is the cross-sectional area, field is like this, in this direction. Normal is also in this direction. Normal is perpendicular to this area in this direction. Theta is 0. Therefore, maximum flux is passing through these two cross-sectional areas. No flux is passing through the curved surface that is mentioned here. Flux is passing only the two cross-sectional area of the cylinder because theta is 0. No flux is passing through the curved surface area because theta is 90. Each surface the Gaussian surface is taken like this. This is the charged sheet. Gaussian surface is passing through like this, and no flux is through this curved surface area because theta is 90, and here only flux is passing through the first and second cross-section area, So, and maximum flux because theta is 0 there. Therefore, what is the flux pi? Flux pi, by the definition, pi is equals to E into S into cos theta. So, E into, what is the surface area now? A plus A, 2A. Flux is passing through two area elements of area A each. Therefore, 2A into cos theta. Theta is how much? For this A, theta is 0. And for this curved surface area, yes, theta is 90. Curved surface area, theta 90. Again, no flux is passing through this curved surface area. Okay, 2A into cos 0. Cos 0 is what? 1. Therefore, it is 2A into 1. That's 2A by Gauss's law. What is the flux pi? Q upon epsilon. What is the Q? Because Q is sigma is equals to Q by A. Therefore, Q is equals to A into sigma. That's all. Now, equating 1 and 2, I got pi is equals to sigma A by epsilon by which was Gauss's law, and pi is equals to, by the definition, pi is equals to E bar dot S bar, that's equal to S cos theta. S is the surface area. Theta is 0, therefore it is surface area is 2A now because the flux is passing through area A, as area A plus A is 2A, therefore total area to which the flux is passing is 2A, therefore E into 2A into cos theta, by the definition of flux pi is equal to E bar dot S bar, that's equal to S cos theta. S is the surface area through which the flux is passing. Okay, here the surface area is A plus A, 2A, therefore E into 2A into cos theta. Okay, understood? Now, 1 and 2 are the fluxes passing through this curved surface area, cross-section area A and A, 2A. Therefore, equating 1 and 2 by 1 and 2, equating 1 and 2, because both are fluxes through same area element 2A. One is by Gauss's law, one is by the definition of the flux. One flux pi is calculated by the definition of the flux. Flux pi is equals to E bar dot S bar, that's equals to ES cos theta. Another formula to calculate the flux is Gaussian theorem. Pi is equals to Q by epsilon naught. Therefore, equating 1 and 2 both are equals to pi. Therefore, 2AE is equals to, that's the end of the derivation. 2AE is equals to sigma A upon epsilon naught. A cancels out. That's why look at the final result. The final result A does not appear. Therefore, any cylindrical, any Gaussian surface you can take. So, the shape and size of the Gaussian surface is immaterial in the derivation. It may be cylindrical, it may be parallelepiped. Okay. Therefore, A cancels out. E is equals to final answer sigma upon 2 epsilon naught. This is the magnitude. E bar is equals to same concept in cap I have given, where E bar is equals to 11. In cap and in cap statement is equal. Therefore, E is equals to sigma upon 2 epsilon naught. Therefore, E bar is equals to, let me give the direction now, sigma upon 2 epsilon naught into n cap. Okay, this is the magnitude. This is the end of the derivation, where n cap is the same statement as that of the y. Okay, n cap is the unit vector radially outwards. N cap is radially outwards, normal to the y is normal to the sheet. The n cap is normal, means perpendicular to the sheet, radially outwards. But n cap is outwards, does not mean that field is always outwards. If sigma is positive, means charge is positive. If charge, then the end of the derivation. Okay. If the charge is positive, Q is positive, then sigma is positive. Therefore, this figure will be a positive number. Therefore, E bar is in the direction of n cap. N cap is radially outwards. N cap is radially outwards. Okay. N cap is radially outwards. Therefore, this is positive. Therefore, field is in the direction of plus n cap only. Means field is radially outwards. Quite obvious. If the charge is positive, field is radially outwards. If charge is negative, Q is negative, it is negatively charged, say. Okay, if the sheet is negatively charged, then automatically sigma is negative. Sigma is equals to Q by A. Q is negative. Therefore, sigma is negative. The negative sign shifted to here. Therefore, field is in the direction of minus n cap. What is the minus n cap? It is minus n cap. Okay. Means field is radially inwards. Quite obvious. The charge is positive, field is radially outwards. Charge is negative, field is towards the charge. Therefore, automatically this n cap gives the direction of the field if the charge is either positive or negative. But direction of n cap is unidirectional. A vector is unidirectional. It is radially outwards. Okay. If the charge is positive, automatically sigma is positive. Then it is plus n cap. Field is in the direction of n cap. N cap is radially outwards. Means field is also radially outwards. Here, figure is written now. Field bar. It is x-axis. Is radially outwards. If charge is negative, sigma will be negative. Sigma is Q by A. Q is negative. Sigma is negative. This negative sign is shifted here, not the sigma value. Sigma value is kept here. Sigma is minus 10. Minus is shifted here. 10 is kept here because magnitude. This is the magnitude of the field. Magnitude of the field is always, magnitude of a physical quantity is always positive. Minus is shifted here. Therefore, the direction of the field E bar is minus n cap. Always I told you unit vector gives the direction of the quantity. The direction is given by the unit vector. Minus n cap. Minus n cap means in the opposite direction of n cap. Now the field is in the direction of what it is. Minus n cap. This is the minus n cap. N cap is outwards. Minus n cap is inwards. Means field is radially inwards. Therefore, field is in this case the field E bar will be inwards. It is minus n cap. When minus you are getting, if sigma is negative. When sigma is negative, if charge is negative. So, charge is negative means the field, quite in basic theory says that field is towards the charge. Therefore, if charge is negative, the field will be in the direction of minus n cap, means field is radially inwards, means towards the sheet. If the charge is positive, sigma is positive, field is in the direction of n cap. means feeding radially outwards. Okay.